Hey, good news. We're here with John, and we're going to be talking about one of my favorite topics, which is chaos engineering. So join us on the Azure Enablement Show. Welcome to the Azure Enablement Show, where we'll be discussing the challenges you and our other tech-savvy customers have encountered. Together, we're going to be talking with experts to find out how they think about these problems, recommended tools and best practices, and tips they've learned from years of experience that you can use. Today, we're going to be talking about one of my favorite subjects, chaos engineering. And I think the best way to do it, because it's definitely worth the discussion, is for me to do it as if I were a customer. So I'm going to switch to customer mode now. Okay, now I'm in customer mode. And now it's going to be my great pleasure to talk to John. Hey, John.
Hey, David.
Hey, so I could really use your help. So I've heard something about it. I've done a little bit of research on the land of chaos engineering, but my boss came in the other day and said to me, like, "This is really cool. We should start doing it. I want you to be in charge of it." And I am a little concerned that my knowledge of chaos engineering isn't all that deep, and it seems like the sort of thing you don't want to get wrong. So I would love it if you and I could spend a little bit of the time talking about chaos engineering, so I know how to like get a good start and how to work with this stuff and not screw up, which is the thing that I'm most concerned about. So let me just start off in the most basic way because I want to make sure that I have it in my head. When somebody asks you what is chaos engineering, what do you tell them?
Yeah, I think the simplest explanation is that chaos engineering is a methodology, and it's all about helping developers to get consistent reliability of their services by hardening against failures that might happen in production. So if you have any particular outages that have happened to your service in the past, major incidents, live sites, challenges like that, chaos engineering is a technique you can use to help prevent those from having significant impact in your production environment.
Okay, so but weirdly enough, like I've heard other things about what chaos engineering is. Can you help me make sure I'm correct? Because like some people seem to think that chaos engineering is like randomly breaking stuff in production. Is that your definition? Like what do you think when people say when you they say chaos engineering to you? You're like, yeah, no, not really. What are the sort of things you hear?
Yeah, I think the biggest factor is that chaos engineering is not just randomly causing failures. It isn't just randomly shutting things down or breaking things in production. You often call that uncontrolled chaos, right?
Hmm.
Chaos engineering is always structured. There's always some thought that is going into acknowledging that you have set things up appropriately, doing some evaluation before you go to cause a failure in your production environment or your pre-production environment. And so I think the main takeaway is that chaos engineering is not completely random. It's not unstructured.
Okay, so I get that it's like, doing planned stuff, doing planned experiments and stuff like that. Um, the next obvious question is like, so besides what my boss thinks, like, how do I know like when we should start doing chaos engineering?
Yeah, I mean, I guess for you as a customer, I'd actually bring this right back to you and say, how mature are your resilience practices today?
I see. We've done, I mean, like, I'd like to think that all our devs are thinking about what happens when things break and like how to make things more fault tolerant and how to recover from issues like that. Sometimes we have the right patterns in place, sometimes we don't. So middling, not, I mean, not certainly not consistent across everything we do, I think is what I would answer.
Right. Yeah. I think in that case, it is a totally valid thing to start using chaos engineering where you have your highest maturity.
Hmm.
A key factor is that your engineering maturity, especially in terms of your resilience practices, have to be relatively high before you're ready to start causing chaos in your environment. And that means things like number one, you should already have great observability of your application or of your service, to make sure that when you go to cause some some sort of impact, you know that you'll be able to see that within your observability data and do some analysis afterwards to deeper understand why that failure occurred and how you might be able to remediate or prevent it from having a broad impact on availability. So, good observability, certainly some sort of metric that represents a roll up of health or of your availability of your service, as well as things like having good resilience practices in place. If you have no backup strategy, no disaster recovery built into the service, really you should be doing kind of a more static analysis of your application, putting in known best practices, such as those available in the well architected framework, before you're ready to start applying chaos to the environment. A final thing is, when you are causing chaos, there's always a certain amount of risk. And so it is important that you also have great live site tooling, great practices around how to handle a incident when one occurs, because your ability to detect and respond to something more severe that might have happened as a result of doing fault injection is really going to gate your success with chaos engineering.
So, I mean, I can see how observability would be super important. If you're like doing experiments, you got to have some way to know, like, how are they going? How did it work? But that leads to the next question, which is, okay, let's assume that I'm not going to do engineering for everything, right? So now the question is like, okay, I've got a bunch of environments that I'm running. Where should I do the chaos testing? Which environment should I be doing this work in?
Yeah, so I'd kind of assume here that maybe, as a customer, you have a pre-production environment, a more development environment, as well as your actual application that is running in production. And
Yeah.
production is often an ideal place to apply fault injection, simply because no other environment that you have is going to have the exact same customer traffic volume, the same patterns with customer traffic, the same security requirements. You may have even further restricted access and limitations and policies in place for production versus pre-production. Scale the scale of the service, and so production is often ideal, simply because of the fact that to really feel confident that you are preventing that outage from happening, that will happen in production, things have to look as close as possible to production. Now, that being said, a lot of the customers that I work with who are doing chaos engineering on Azure have suggested that oftentimes risk tolerance isn't quite at a level where they're comfortable to be doing this sort of fault injection in production. And it's sometimes we hear this as a, hey, we haven't built up a lot of confidence in our ability to do fault injection safely. We want to start in pre-production, where if we do have a bigger impact, we know that we're not going to impact 100% of our real customer traffic. And maybe some of those tests will move into production as we build up that confidence. But then we also have some customers who say, look, what we are doing is simply too mission critical in production to ever risk causing some sort of impact. Certainly if you were in an industry like healthcare, finance, utilities, there are emergency services that run on Azure. And if you were to be intentionally causing a failure that caused an outage that prevented an ambulance from getting to somebody in need on time, there would be a heavy weight on your conscience. And so a major factor too is, what's your tolerance for risk for that production environment, to determine whether it's really suitable in the long run, even to be doing some of your chaos in that production environment. I'd also suggest that chaos engineering doesn't always have to happen in a close to production or production environment. In shifting that quality to the left or earlier in the development cycle as part of your CI/CD environments to prevent regressions in some of the resilience you've built up. So, a great example within Microsoft is we're continuing to build up our own set of CI CD chaos tests that are applied to every Azure service to avoid a failure in, as an example, Azure Active Directory, right? Every service continues to leverage Azure Active Directory to do our authentication, but we need to make sure that as we continue to increase our dependence on that identity provider, if that identity provider were to have a failure, it doesn't cause a catastrophic failure in any of our Microsoft Cloud services. And so that's an example where, as we continue to add new API calls and new services, we always want to be defending against and really prevent any regression in the resilience we've built up against a failure in Azure Active Directory.
Well, as you talk about sort of the larger organizational context, right? When you're talking about, everybody depends on this sort of thing, it makes me start to think that like maybe I need to think carefully about who has to be involved or what we need, what other things we have to have in the context. I mean, we already talked a little about good observability, but what else has to be in place before we feel super competent to get going on this?
Yeah, I think more than anything, a culture of quality is critical to be able to be successful with chaos engineering. Now, when I talk about this idea of a culture of quality, really it is great communication and coordination across teams so that when you go to apply some sort of failure, you're working together with the same mission being improving the resilience of the service. A very similar and well-known concept in the site reliability engineering space is avoiding blame, making sure that you're not trying to pinpoint a person or a line of code that somebody wrote as the source of the issue, and instead focusing more on improving resilience and on the outcomes that come from collaborating and learning and growing together. Apart from that sort of conceptual, cultural transformation that you have to have in place, I'd also suggest that ensuring that your environment has appropriate load and traffic in it. There are some possible cases where you can apply chaos engineering where there is no load on the service, but generally speaking, you do want some amount of activity happening in the service, so that that availability metric, though all of your observability data, is closer to what's happening in the real world in your production application.
Well, so presumably it makes sense because, I mean, how do you know if your thing is working if there's nothing attempting to see if to use it? So that makes perfect sense to me.
Yeah.
Um, when I'm building systems that are chaos testable, right, that's the next thing. Like presumably, like this becomes like a really cool thing for us. We've talked about paying attention to resilience and stuff like that. Are there things that the people that are building the systems can do to make an environment more conducive to chaos testing, to being able to do this sort of experimentation?
Definitely. Yeah. Certainly making sure that you have, uh, number one, a good understanding of your service architecture, having that sort of either visual map or some sort of kind of mental model of what the known dependencies are and where these services connect to each other is important. But beyond that, having good practices around understanding blast radius, ensuring that you know how to contain impact of an outage. These are the sort of things that really you need to be thinking about in your environment before applying chaos engineering. We talked a little bit about the cultural aspect of it. It isn't about finding blame, it's about making sure that everybody's learning and growing together. But apart from that, just ensuring that you feel confident that you have done your due diligence in terms of applying site reliability engineering best practices before applying chaos will help you to really learn something new. When you go to apply chaos, you're not going to learn something that you already knew, right? It isn't useful for me to say, hey, we shut down all the compute in a region, we're a single region service, and the service availability dropped to zero. right? It's more interesting to say, hey, we expect that our service can handle and a regional outage and can just simply swap over and leverage another region. Um, let's ensure that that really is the case with the architecture that we've already prepared to do that.
Okay, so now I have one last question. It's kind of got two parts. I'm going to go off and try to convince other people this is what we need to do, or talk to my management or talk to my management's management about this sort of stuff. And so the first of the two parts, and I'll ask you the second one after the first part, is what do you think I'm going to hear in terms of worry from these people that I'm trying to convince? Since I know that you've talked to other customers like me, what do you hear like oh, we can't do chaos because, or we're worried about, like what do you think I'm going to be hearing when I as part of this process, as a natural sort of response?
Uh-huh. Yeah, the things we hear the most about are the fact that customers acknowledge, like we do, that fault injection is not being simulated, right? We are not simulating a shutting down a virtual machine or breaking the network. You might be simulating an outage or a bigger failure scenario, but those faults that are getting injected are real. We're really shutting down compute. We're really breaking the networking. And so in those cases, two major areas of concern that come up are accidental or malicious fault injection. Should somebody be playing around and have too much access, and either accidentally or intentionally try to cause a failure in production or in pre-production that would harm the business? And secondarily, chaos is intended to reveal things about your application that you didn't know before, and that can mean that something you thought might have caused a slight dip in availability or maybe a slight addition to latency. If it starts to spiral out of control and you come to discover that the impacts are more severe, customers often ask us, hey, how do I stop this? How do I quickly roll back and mitigate the fact that I was applying that failure? So that if things did go awry further than what I expected or further than I wanted, I can undo that and not make that something that impacts the business any further than it really had to.
Okay, so the second part of my question that was really good is, I'm in these conversations, I'm hearing these things, and I have to tell them from our experience, from the experience that you've seen, what sort of things go right? Like what will we get out of this? Like, do you have any examples of chaos engineering helping, and what, like how do what could go right rather than what could go
Yeah.
wrong is my question.
Yeah, I mean, I think this is the greatest way to justify investing in chaos engineering within a company, is to help prove to your leadership that this is not unnecessary risk. It's actually necessary and important risk to be taking to cause these sorts of failures. And why is it a necessary risk? Well, it helps you learn about your system and it helps you to improve your system. And while it is often hard to quantify, being able to quantify impact of your outages to leadership can really help to get across that importance of learning and improving a system. And I'll give you one concrete example. The Azure Key Vault team has been using Chaos Studio, which is our tool for doing chaos engineering for the Azure cloud. We also use it inside Microsoft. And the Azure Key Vault team has been using it against their infrastructure for quite a while to discover and improve quality of their service. They recently were doing some work with virtual machine scale sets, and some of their underlying architecture depends on the virtual machine scale sets that automatically scale up based off of load. And they went and leveraged Chaos Studio to do apply some stress. I believe it was CPU pressure applied to all of the VM nodes in a virtual machine scale set. Their expectation was that the virtual machine scale set would simply scale up, add instances, in order to handle the additional load being applied on the system so that there would be no customer impact. Now, they were doing this all in pre-production, making sure that we're not impacting customers, we're doing this safely. And they actually discovered that when they went to apply that additional CPU pressure, The virtual machine scale set did not scale up. They did start to see additional latency in their synthetic tests, their synthetic load applied to the environment. And come to find out, it was something really trivial. It was a slight misconfiguration in an auto scaling rule that they had for that virtual machine scale set environment. And so the things that you can learn and improve with chaos are vast. They can be small little nitpicks in the service that have a massive amount of impact on availability. Certainly, you could envision how that small tweak to an autoscale rule that the Key Vault team learned about in pre-production avoided some much more significant outage that might have occurred in production should that not have been remediated.
Well, I totally dig that, and I like the fact that this might help us learn about things that we wouldn't be able to learn any other way, and that seems very cool. Except for like except for the hard knocks, like through an outage, which is not the way I particularly want to learn about issues with our auto scaling configuration.
Right.
So I have to say I'm sold. I really would like to try to do this, and I'd like to get started, but I'm not quite sure. And is there any, you mentioned Chaos Studio a couple of times. I would love to see it because I'm a bit of a visual learner. Can you or somebody else you could recommend? Could they show me like how we would actually do some of this sort of stuff?
Yeah, I mean, it almost sounds like you know that there's somebody who can help us with that. Shrunga from our Azure Chaos Studio PM team is here, and she would be more than happy to introduce the service to you, give a little bit of a demo, and talk you through how it all works.
Awesome. Well, I will definitely talk to Shrunga next. And John, thank you for your time. Let me get back to host mode. Okay, back again. So I want to thank John, and I want to thank all of you for taking the time to watch us. I really hope you'll join us in the next one, because that's going to be a really cool one, because we're going to get a chance to see how this looks like when it's actually happening. So thank you very much for joining us, and I hope you'll join us on the next episode of the Azure Enablement Show.